Hi, everybody. I'm continuing today with this remarkable book, Steven Pinker's Enlightenment Now. We're in the second chapter still, and we're investigating the idea of information. Steven is starting to talk about how information mediates these forces of entropy and evolution. So we'll start here. Information is what gets accumulated in a genome in the course of evolution. The sequence of bases in a DNA molecule correlates with the sequence of amino acids in the proteins that make up the organism's body. And they got that sequence by structuring the organism's ancestors, reducing their entropy into the improbable configurations that allowed them to capture energy and grow and reproduce. Information is also collected by an animal's nervous system as it lives its life. When the ear transduces sound into neural firings, the two physical processes, vibrating air and diffusing ions, could not be more different. But thanks to the correlation between them, the pattern of neural activity in the animal's brain carries information about the sound in the world. From there, the information can switch from electrical to chemical and back as it crosses the synapses connecting one neuron to the next. Through all these physical transformations, the information is preserved. A momentous discovery of 20th century theoretical neuroscience is that networks of neurons not only can preserve information, but can transform it in ways that allow us to explain how brains can be intelligent. Two input neurons can be connected to an output neuron in such a way that their firing patterns correspond to logical relations such as and, or, and not, or to a statistical decision that depends on the weight of the incoming evidence. And I find this really remarkable because it's saying there's some sort of logic actually built into the brain. And come on, you might not actually think that. That gives neural networks the power to engage in information processing or computation. Given a large enough network built out of these logical and statistical circuits, and with billions of neurons, the brain has room for plenty. A brain can compute complex functions, the prerequisite for intelligence. It can transform the information about the world that it receives from the sense organs in a way that mirrors the laws governing the world, which in turn allows it to make useful inferences and predictions, internal representations that reliably correlate with states of the world and that participate in inferences that tend to derive true implications from true premises, may be called knowledge. We say that someone knows what a robin is if she thinks the thought robin whenever she sees one, and if she can infer that it is a kind of bird which appears in the spring and pulls worms out of the ground. Getting back to evolution, a brain wired by information in the genome to perform computations on information coming in from the senses could organize the animal's behavior in a way that allowed it to capture energy and resist entropy. It could, for example, implement the rule, if it squeaks, chase it. If it barks, flee from it. Chasing and fleeing, though, are not just sequences of muscle contractions. They are goal-directed. Chasing may consist of running or climbing or leaping or ambushing, depending on the circumstances, as long as it increases the chances of snagging the prey. Fleeing may include hiding or freezing or zigzagging, and that brings up another momentous 20th century idea, sometimes called cybernetics, feedback, or control. The idea explains how a physical system can appear to be teleological, that is, directed by purposes or goals. All it needs are a way of sensing the state of itself and its environment, a representation of a goal state, what it wants, what it's trying for, an ability to compute the difference between the current state and the goal state, and a repertoire of actions that are tagged with their typical effects. If the system is wired so that it triggers actions that typically reduce the difference between the current state and the goal state, it can be said to pursue goals, and when the world is sufficiently predictable, it will attain them. The principle was discovered by natural selection in the form of homeostasis, as when our bodies regulate their temperature by shivering and sweating. When it was discovered by humans, it was engineered into analog systems like thermostats and cruise control, and then into digital systems like chess-playing programs and autonomous robots. So we're going to let this be good for today, but I find this incredibly useful because, well, for me, it sometimes seems like things are happening in a random way, or there's a lot of random things that are happening, which may be true, but there's some kind of case being made here that the intelligence or the way that we process information is actually built into the brain, and it's working all the time to try to make sense in a logical way and help us to achieve our goals. I know there's a limited traction that statement might have, but we're going to find out more in the next episode of me reading Steven Pinker's Enlightenment Now. So thank you very much for being here again.